All right, so now we're going to be given a prompt that's asking us to go backwards, right? So it's asking us, instead of what is the z statistic and what is the corresponding probability within this range, now we're being asked what's the minimum x value or what's the maximum x value. So let's go ahead and get the prompt down. So we are told there's a tire and rubber company, and they wish to set a minimum mileage guaranteed. On their new tires, right? Their new MX 100 tires. Tests reveal that the mean mileage is 67,900 miles. The standard deviation that we have is 2,050. What are the units of the standard deviation? Always the same units as the mean and the data, right? So it's miles. And we're told that the whole thing follows a normal distribution. So sometimes you'll see that represented like this. Tilde means it approximates, and then this large fancy N to mean that it's a normal distribution. In fact, what you will probably see is you'll see all of this stuff like this. Well, let's not use commas. Where the first value is expected to be that mu, and the second value is expected to be the standard deviation. So with all of these things, it is best to draw a sample graph, right? So you draw a sample graph, probably give yourself a little bit more room than I did. Okay. You do your best to approximate a curve. You pretend that it's symmetrical even when it's not. Again, I'm an economist, not an artist. Give me a break. And we were told, and then we label the things, right? So this is 7,900. And then the other part that we can put here, just to give us a little bit of context, is that this whole half of this is going to have a probability of 0.5000. So we are asked the minimum mileage so that no more than 4% of tires are replaced. So the minimum mileage for the guarantee, right? So that no more than 4% of tires are replaced. So this 4%, right? So a lot of times when we are given these questions, the last bit of information that we're given in the prompt has to do with the x value, right? But this one, we're solving for the x value. So that means that this is either going to be my z statistic or it's going to be the area under the curve. And since it's giving to me in percentages, right, or probabilities is another way to think about it, right, 4% or 0.04, we know that it's going to be the area under the curve. So what we're looking for the value of x that's going to make this whole region over here equal to 0.0400. So when we So now the next part of this is, since this whole thing is 0.5, right? Since this whole half of this is 0.5, the value, and remember our z statistics go from the middle out, right? From the middle out. So if this is 0.400, then what does that mean about the part here? The part here has to be 0.56 or 0.4600. And why is that? Because these two things have to add up to this, right? 0.04 plus 0.46 is going to equal 0.5. So we've graphed it. We've identified where the cutoff is. We've identified the probability under the curve that's associated with this number, but we know that the z statistics are from the mean outwards. And so instead of finding this z statistic in the table on the back of the book, you're going to be finding this statistic in the table of the back of the book. So you're going to be looking on the z table, and you're going to find .03, 0.04, 0.05, 0.06. So you'll start to get a little bit closer. At 1.74, we've got 0.4591. At 1.75, we've got 0.4599. And at 1.76, we've got 0.4608. So we're going to take the value that's closest but not over, which means that the associated z statistic to what's going on here is going to be equal to 1.75. Does everybody understand where we're getting this 1.75? Okay. And then in order to actually do this correctly, I know this is like probably the hairiest, most complicated problem that we've had so far. In order to do this correctly, we do have to figure out, is this a positive 1.75 or a negative 1.75, right? So we know that the chart only has the positive values because they're symmetrical. So we have to kind of use a gut check for this. We have to go back to the prompt, go back to the graph that we've graphed, and figure out, okay, it's to the left of the mean, which means that all of my z statistics, right, my z values, they're always negative over here. What's a better way to do this? And then they're always positive over here. And so since it's to the left of the mean, that tells us that it's going to be a negative z value, right? So instead of being 1.75, it's actually negative 1.75. Now we still found positive 1.75 in the chart, in the table, right? Because there's only positive values in the table. But then we have to run it back through the context of the problem in order to assign that negative sign to it. If we don't assign the negative sign to it, the next part's not going to work. So now that we have this, now we can use our z statistic formula, right? X minus mu over sigma. And so if our z, if we know that we want to be 1.75 negative in the standard normal distribution, right? Negative 1.75 here. And then this is going to be 0. This is my dollars. This is my z. So in order to get there, we're going to have some x that's subtracting this 67,900 number, and then we're going to have to divide it by the standard deviation, which we were told is 2050 in the prompt. So solving for x, we end up with x is equal to 64,312 miles. And then we would replace this x here with that 64,312. And then again, this is an opportunity to, kind of run that through your gut check in terms of the way that you drew this graph. Number one, is it less than 67,900, right? That's your first gut check. If it's more than 67,900, you did something wrong with your math. You got to go back to the drawing board there, right? Questions on this particular problem? Like I said, it's a bit more complicated because we have to understand not just how to set it up, but we have to understand the fact that our z statistics are not going to be correlating to this 0.04. It's going to be correlating to the 0.46 because, again, everything goes from the mean outwards. And then we have to find that 0.46 in the table, and then we have to run it through the context of if it's positive or negative, and then we have to plug that in and solve for that x to get that final value. Questions on that?